This lesson is on enlargements, and we're going to be taking two-dimensional shapes and trying to enlarge them. So what I'd like to do is just have a go at this little triangle here. Can you enlarge it by scale factor 3? And this rectangle here by scale factor 0.5. What could this mean? Just see what you get, and then I'll talk through the answer. Well, when I say enlarge the triangle by scale factor 3, I basically mean I'm timesing the sides by 3. So if the sides were 1 in length, then suddenly they're going to become 3 because 1 times 3 is 3. And then for a height of 2, I'm going to do 2 times 3, so I'm going to get 6. And this would be a possible triangle that I could draw. I'd have to, fill it in, but it would be that sort of thing. I could have it anyway. I could have it over here. I could have it even over the shape. But yeah, I'll just leave it there for now. For the second one, scale factor 0.5, I'm going to be doing the same sort of thing, but this time I'm going to be timesing through by a half, or 0.5. So now the width of this one is 6, so if I have that, I get 3. So I'll start it off over here. And then the height is 4, so if I have that, I get 2. And this would be a possible enlargement. Again, I need to maybe, well, that didn't quite look straight. I need to, shade it in for it to look exactly the same, but you get the idea. It's pretty good, and again, it could be in all sorts of different places. Now, if you understand that, then you've understood half the battle in doing enlargements, but the second half of the battle is the most complicated bit, and it's as shown in the title. There's actually something we need to get our enlargement in general. It will also be described, like there will only be one place that could be correct, because there's something called the center of enlargement that decides where it ends up. And here you can see I've got a center of enlargement, and I'm kind of bringing out ray lines that go through the points, and that ends up with this larger one here. And I'm going to show you in GeoGebra a bit more about what I mean. Actually, before I do that, I'm going to show you, where has this come from? So here we go. Here's this looks like a home cinema, pretty snazzy, and we've got a projector at the top of the room, and it has at the top of it has like a small image of the film essentially that's being played, and then it projects it out onto a bigger screen, and then you watch it, and that is precisely what an enlargement is. You've got this 2D film, you make it bigger, and you kind of project it out, and you get this final image. If we make it into a sort of slightly simpler diagram, then here I go. Here's my center of enlargement. This is me sort of projecting out from the focus, I guess you might call it, and then I go from this smaller image of this person, and then I go along, and I create this bigger image of the person on the screen. So I've got a light. Yeah, the light source is sort of the center of enlargement. It's ray lines, we call these, that are coming out, and we get this larger image. So if I do this in a GeoGebra, then we can see what's going on. I've got my center of enlargement that I've defined. I've got my shape. Now, if I want to, at the moment, I've got a scale factor of 1, so that actually is exactly the original shape. But if I make it 2, then what is going on? Basically, instead of going just to A, I go double the distance to get to this A prime over here. And from B, distance to B, I do double the distance. So that's one way of thinking about it. You literally just draw a ray line that goes through the corner, and then if you've got a scale factor 2, you just start from the beginning again, and you double it. If we go to 3, then, okay, now instead of going to A, I go 3 times as far as A, and that takes me to A prime. You can also look at if it's a half, for example. Instead of going the distance to A, I go half the distance to A, and so on. You can do 0.2 and so on. It gets smaller. You can see so it's getting smaller and bigger. And also, as you change the center of enlargement, that changes where it ends up. The ray lines are moving, so they are helping to define. The center of enlargement is uniquely defining where the final enlargement is. Okay, so if I go back to 2, you can see as I move my center of enlargement around, all the ray lines move, and I can, if I want to send it over here, I need to move it to the top right. Okay, this before we do an example, I want to talk about another way of thinking about this because this is the way I prefer. You can draw these ray lines, but your line's going to have to be really accurate. Another way of thinking about it is, well, I'm going from the center of enlargement to A. I'm actually going 3 along and 2 up. If my scale factor is 2, I can, if I go in this, like double the distance now, I can, instead of going 3 along and 2 up, I can go double those distances. So I can do 3 times 2, which is 6, and 2 times 2, which is 4. So instead of going along 3 and up 2, I'm going to go along 1, 2, 3, 4, 5, 6, and up 4. 1, 2, 3, 4. This is how I like to do enlargements because I don't need to draw the ray lines. It doesn't require me to draw them accurately, and you can get to where you need to get to basically. Like it all works out. It's good to like give one more example. Let's do B. So instead of going along 3 and up 4, I'm going to double both of those. I'm going to go along 6 and up 8, and that does take me to B prime. And you can. This is exactly what is going on with the ray line. So both of these methods are essentially the same thing. The advantage over the second method I talked about, this going along and up, is that you're basically using the concept of the gradient, but you're doing it really precisely. Whereas if you draw a line, what if you just miss it slightly, and like you might end up over here at this point, and you might think that the point is at 22, 0 instead of 22, 2, 1. Actually, the axes are not labeled perfectly here, but this would be 22, 1. Okay, hopefully I've made that clear. Let's see. Let's do an example to have a go. So I'm going to talk about the second method, this idea of using the gradient, and I'll bring in the ray lines at the end just so you see that it works. So example 1, enlarge the triangle by scale factor 3 about the center of enlargement, this little dot here. So I'm going to pick a point, here we go, and I'm going to count how many I go along and up. And in this case, it's 2 and 1. So I'm going to times those by 3. So 2 times 3 is 6. And I'm going to start from the center of enlargement again and now go along 6. So there we go. If I enlarge it, instead of going along 2, I'm going to be going along 6. And instead of going up by 1, I'm going to times that by 3, and I'm going to go up by 3. So there we have it. This is my new point. And it's got to be said, if you're really confident at this point, you can actually draw the shape, because we've already saw in the first part of the lesson that what's going to happen is that this triangle is going to be 3 along and 6 up. But I know the bottom left is going to be the bottom left on the new shape, like the equivalent. So I can just go 3 along and I can go 6 up, and I got my shape straight away. So there's not much to it in that case. Got a shape and it's finished. Let's just check it though. Okay, because these definitely should at least check one point. You can do it for all the points if you like. All right, let's choose the bottom right point. So instead of going along 3 and up 1, it does get a bit messy if you start writing all these things on. I'm going to multiply each of these by 3 because that's my scale factor, and I'm going to go along 9 and up 3, and that would take me to here. So I can see that it works if you count them through. And you can do it if you want to do it for the last one. You can maybe I'll go along 2 and up 3, times them by just run out of colors here. I'm going to use pinks. Times them by 3, so it's going to go along 6 and up 9, along 6 up 9. We do get to this very corner here. So it works, really solid method. This is the one I advise. If you want to draw ray lines, you can. And what you'll do is because actually this will come into enlargements at a later point. I should use a different color here. Hold on. I'm going to use orange. So for the ray lines, right, I'm going to go from the center of enlargement through the corner, just keep going, and we see that it matches up. Okay, and you can just you would measure the distance. So instead of going this distance, I would times it by 3, and I would go this distance. It will work out. It's just you've got to be really accurate with your ray lines, that you don't go off center slightly. Obviously, the bigger the grid, the more likely you are to just like not quite have the same gradient. So that's there. I'm going to keep using the number method, but be aware of the ray lines as well. Right, if you're confident with that, then try this second example yourself. Otherwise, and by the way, the center of enlargement will uniquely define where it is. This is the one and only answer. If you drew it somewhere else, then you've enlarged it by a scale factor 3, but you've not enlarged it by the center of enlargement. This is the most common mistake I see. People think, oh yeah, that's the center of enlargement, so I'm just going to stick it right there. Well, that's not actually what's happening. We need to consider the ray line idea. That is incorrect. That one is correct. Okay, anyway, try the second example. All right, I'm going to go through this one. So bottom left, I'm just going along 1. If I times it by 3, then instead I'm going to be going along by 3. Straight away, I've got the bottom left-hand corner. And the quick thing to do then is simply then, draw my shape. Hold on. Draw my shape. If that's the bottom left-hand corner, then I'm going to be going along 3. I'm going to be going up by 6. Job done. Let's just check though, at least one that it works. Right, let's pick I don't know, top left. So I'm going to go along 1 and up 2. 1 and 2. Let's just check it. So if I times each of those by 3, I'm going to be going along 3 and up 6. There we have it. It is in the right place. If I want to draw my ray lines in, maybe a ray line is just a good idea at the end if you got time, just to check that it seems to be in the right place. In this case, it's just those two because these 2 points have the same ray line essentially. Okay, good start to enlargements. All right, if you're feeling happy, try these 2 examples, and I'm going to then go through both of them. Same idea, center of enlargement here, but now I've got a different shape, but I've also got different scale factors. All right, let's go through this. So, center of enlargement, I'm going to pick the bottom. I always go with like the closest one. So, bottom left is 2 and 2. Scale factor is now 2, so I'm going to times each of these by 2, and I'm going to go along 4 and up 4. Okay, and then I'm gonna take it steady. I'm gonna choose the bottom right. So now I am going along 4 and up 2. So if I double these, I'm going to be going along 8. So here and up 4. There we have it. I can connect these if I want, and I can see my shape forming. Like if it's symmetrical, so it's gonna have a height of 4, not 2. And I could have checked that other point, but there we go. That's going to be my shape. I've not actually done the last point. I've used my knowledge of the original shape to get that top point. But I could, just to check it, I could draw that ray line in, and yeah, it looks like it's working. Looks good. Let me just go for it again. So I'm going to the ray line. I just got to carry on the same direction. That's the important point to make. Here we go along the same direction. Yep, that works. Okay, this one here, it's not meant to be a trick question. It's just meant to get you to think about it. When you enlarge by a scale factor 1, it stays the same. You're not going to be asked in a GCSE exam to enlarge by a scale factor 1, but they could test you on the idea. They could say what would happen if you enlarge by a scale factor 1. So I just thought I'd get you to try this one. Essentially, we're going along 1 and up 2, times it by 1. Oh, we're still going along 1 and up 2. All these points stay exactly the same. Okay, so there's my new shape. All right, bring in the decimal, the ones below 1. Can you enlarge this rectangle by a scale factor 0.5 about the center of enlargement? Give it a go. Right, I'm going to go along. I'm going to pick the top right point. So it's along 2, down 4. Multiply those by a half. So essentially do 2 divided by 2. That's going to give me 1. 4 divided by 2 is 2. So my new top right point is there. I can then, if I'm feeling confident, probably draw the rest of the shape. Because instead of it being 6 in length, I'm going to divide that by 2, it's going to be 3 in length. And instead of being 4 in height, divide that by 2, it's going to be 2 in height. And that is my shape coming out straight away. Just going to check a point. So let's go with bottom left. Right, for bottom left, where's my center of enlargement gone? There it is. So I'm going this way, going to the left by 4, and then down, that's 4, 8. So if I take this and I halve them both, then now I'm going to be going along 2 and down 4. Yep, it works out to the bottom left. So really confident that that one is correct. Again, I can draw the ray lines in. And I didn't talk about this loads at the start, but you see when you get when you have a scale factor that's more than 1, then it goes beyond the shape. Like you have the original shape is in between your new shape and the center of enlargement. I suppose you could say that you have your center of enlargement and you push out and you project beyond it. When you have a fractional center of enlargement, then it's that actually the new shape is in between. And we saw it from the 1, so it goes like here would be if it was a fractional 1, it's 1 when it's the exact original shape, and then to go beyond it, it's going to be more than 1. The other thing to say is if I start, so when I went from the green shape to the new shape, that was a scale factor 0.5. But if I go from this new shape back to the old shape, it would be a scale factor of 2 using exactly the same center of enlargement. You can find them in pairs essentially. Like one going to the other one is going to be the reciprocal of the other one going back to the original one. I hope that makes sense. Last one, scale factor 0.25. Why not? That is exactly the same as a quarter. Slightly different center of enlargement. Let's pick the top left point. So I'm going along 2 and down 4. So now I'm going to have to divide both of these by 4, essentially. So I'm going to do 2 divided by 4. That's just going to be a half. I'm actually going along a half and then down by just 1. So that is going to be the top left point. Okay, this is getting a bit more difficult to understand. So let me do one more because it's not exactly on the grid line. Okay, this maybe is a nicer point to have done. So this one top right is along 4 and down 4. So if I divide that both by 4, I'm going to get 1 and 1. So I'm going to go along 1 and down 1. And I can see that's going to be the top of my shape. Instead of it being 6 along, it's going to be 1.5 along. I'm pretty happy with it now. Instead of it being 4 down, it's going to be 1 down. That is going to be my shape. Let's draw the ray lines in. Yep, happy with the bottom of it as well. Okay, and you can see all the corners match up. Note to go from this new shape back to the old shape, that will be a scale factor of 4. Okay, time to do some more practice. Not loads of questions, but a few select questions where you've got different centers of enlargement, different scale factors. So if I want to enlarge this one here that I'm hovering over, that will be scale factor 3 from point C. So you need to start at that center of enlargement. See how you get on. It's really hard to make a puzzle that forms a word when you're just doing enlargements, just to say. So this doesn't form a word, but you should be able to figure out at the end if you got it correct. You'll see what happens. Anyway, pause the video, give this a go, and hopefully you might have 1 or 2 questions at the end, but hopefully you'll be happy and get the correct answer. Okay, going to show the answer in about 5 seconds. So I've not drawn all the ray lines in, I've just given the final answer here. This is what you get. You actually get a square in the middle. So if you didn't quite get that, it means you didn't perfectly do your enlargements. The interesting one that I tend to get asked about is like, how do you do this one here? scale factor -1. Normally people kind of figure out well, it's got to be where the missing piece is. That's coming up. I've thrown this in today because actually it is possible to have not just scale factors of 3 or 1 or 0.5 to make it smaller and smaller and then go to a negative scale factor. An extension to today. So you've mastered enlargements. You think you can do fractional ones, you can do positive ones that are like nice numbers. Not going to move on to negatives quite yet, but here's an interesting task. So what I want you to do is actually you can get any kind of piece of square paper, make sure it's got like a decent number of squares on it, and then there's a question: how do you enlarge a given triangle? I've gone with this one. You might go with something different. Of scale factor enlargement, say 3. Again, you could change that. And you could enlarge it about a scale factor, a center of enlargement of your choice. So I might start out, I don't know, like here. The question is, where can the center of enlargement be so that the image lies completely on the grid? So if I do it for this one, I'm just going to do it with the bottom left point. I go along 2, up 1. So I times both of these by 3, and I'm going to go along 6 and up by 3. And here's my shape. It's going to be, instead of 2 along, it's going to be 6 along. And oh no, it doesn't quite fit on the grid. So actually that one there is not going to be a possible point. I can see it doesn't work. And actually anything along here, it's like I've almost, I'm defining a region. Anything above this region will not keep the shape inside my squares of paper. Yours might be slightly different because of how you've set up the problem. So I can rule that one out. It's going to have to be above. It's going to have to be above this line. I can rule all of these points out. Okay, maybe I shouldn't. No, I'll cross it out like that. That's okay. If I pick a different point, say, I don't know, here, let's see if this one works. So now I go along 1 and down 2, multiply those through by 3. So I'm going to go along 3 and down 6. And that was the top right. This is going to be okay. I've got my shape 4, 5, 6. Here. There we go. This is within the grid. Where can the center of enlargement be so that the image lies completely on the grid? This is going to be one of the points where it does. And basically, you're going to get a little area of points that are possible and the rest are not going to be possible. So as an extension, that's what I'd like to do. You might then want to think about, what if I change the scale factor? What if I changed it from a 3 to a 2? How would that affect things? What if I changed the triangle? What if I changed, I think that's mainly it, because the center of enlargement you are changing throughout. So I'd focus probably on, if you do get through the first bit, on changing the scale factor. Okay, have a go. Well done on your efforts on enlarging. Negative enlargement is coming up.